Alright everyone, welcome to the video about question 13. So question 13 is about bond enthalpy, and the other way that you can say bond enthalpy is bond dissociation energy. Ooh. Again, an annoying scrolling thing when you bond dissociation, and I did it again, energy. And again, you guys were confusing this on the test. So when you're doing heats of formation, which is the previous problem, it's products minus reactants. When you're doing average bond enthalpy, or bond dissociation energy, add up all the bonds on the reactant side, and you add up all the bonds on the product side, and the ones that are on the product side are negative because those bonds are being formed. So this energy here is needed to break an N-N triple bond, or if it's negative, the energy released when an N-N triple bond forms. Now this was sort of doing something we didn't explicitly do in class, but the AP exam can throw you those things. Is that they gave you the total delta H value, and they wanted you to calculate the bond enthalpy for F. So this was an algebra problem. So let's take a look at, so we have the products, and so they're in the products, there are 3 bonds. So there are 3 NF bonds, and each NF bond has a bond enthalpy of 272. Now be careful, there were 3, and this is where a lot of you made a mistake. There are 3 NF bonds, but there's 2 of them. There's 2 NFs total. So there's actually a total of 6 NF bonds because there's 2 NF3 molecules. And that was a mistake a lot of you made, is that you forgot to sort of multiply the fact that there was 2 NF. So there's per NF molecule, there's 3 NF bonds, but they were 2 molecules because of the 2 here. And now, this value is going to be negative. And the reason why it's going to be negative is that it's in the products. Okay. Plus, there's 1 N triple bond, which is 946. Now, we don't know the value of the F bond, but whatever it was, it would be multiplied by 3. Because there's a 3 here. So that's 3x, and all of this would be equal to the delta H, which is negative 264. So again, remember to make the energy of the products, or the bonds in the products, negative, because energy is being released, while the energy of the bonds of the reactants is positive because they're being broken. Now you need to AP button press. So when you button press, you're going to enter this part of the equation. And when I did that, I got negative 692 plus 3x equals negative 624. Now this is just algebra. So we're going to add positive 962 to both sides. And we get 3x is equal to, let me just do this math. So negative 264 plus 292 is 428. And then we divide both sides by 3. And we get x is equal to about 142 or 143, depending upon where you're doing. And I feel like I added one of these numbers wrong or wrote one of these numbers wrong. But anyway, that's the general process of doing these numbers, doing this process. Again, the products are negative, these values. So you put them in a negative, and remember to multiply by the coefficients. And then the reactants will stay positive. Alright, now B says, determine how many grams of NH3 were produced if this reaction was placed under a calorimer that heats up 50 grams of water from 21.0 to 40.04, and it tells you the specific heat of water. So I am now actually going to, so if you want, pause the video and write this, But I am now going to erase this because I only really need this value now. Okay, so now for B, we're heating up water. So whenever we're heating up water, we need to use the formula Q equals MC change in T. Okay, so our mass of our water was 50 grams from here. Our specific heat, as we all know and says in the problem, is 4.186, or 4.18. I use 4.186 in honors. And to get the temperature change, we subtract these two, which I believe when you do that subtraction, I think I already wrote it, is 19.4. And then when you do this multiplication, you get 4,005. 4.6 joules. Now this is in joules because the specific heat is in joules. So then what you need to do, because we're going to be using this value here, or this value here, is we needed to convert it to kilojoules. And let me erase this stuff on the previous problem. So when we convert this to kilojoules, we move the decimal place 3 places or divide by 1,000. So that is 4.0546 kilojoules. Okay. So we know that that's how much heat was produced. And we have to figure out how many grams of NH4 were needed to do that. So we're going to start with this, and we know from the equation that when you do this reaction, you release 264 kilojoules of energy. And we want to know for NHF3 for every 2 moles of NH3. I'm sorry, NF3. I don't know why I keep on saying NH3. Okay, we're using, why there's a 2 here is that there's a 2 in the reaction. So this is the delta H for the reaction. So for every 2 moles of this, you release that amount of energy. Okay? And then our last step, once we get it to moles, is to multiply by the molar mass. And then 1 mole of NF3 is equal to 71.1 grams. That's the this is the molar mass of NF3. And when you do all this math in your calculator, you end up getting about 2.18 grams. A lot of you forgot to do the conversion, so you got 2,180 grams as your answer. So then, again, this goes with question 14 on the redo homework.